let's review projectile motion and what are the assumptions made and so on, and what's going on. First of all, let's remember what is a projectile? If something is a projectile, what is it? It's an object that is moving through the air, yeah. And now, do we worry about the air, though? No, we don't worry about the air. We don't worry about air resistance. So it's an object that's moving through. So what force is acting on the object that's moving through the air? Yeah.
Gravity.
Yeah, force of gravity. So a projectile is an object where the only force acting is the force of gravity, also known as weight. Okay? So now let's review the different kinds of problems that you might see on the AP test. First of all, let's look at the most complicated kind. What if I launch an object like this? So this is the initial velocity, and it's at some launch angle theta. And it's going to go up and down. Whoops, I've got to draw more. That. So it's going to go reach some maximum height, and it's going to come down. Now let's think about what's going on with the projectile. Let's draw a free body diagram of it. It's a really easy free body diagram. Like, let's say I launch a football or something, and it's going up. And let's look at it right here. What's the free body diagram of this thing going to be? Huh? A downward arrow. And it's just going to be mg. Now, if we were going to include air resistance, we might have a horizontal force on it, but we don't. There is no horizontal force acting on it. So, I've drawn my free body diagram. Let's sum the forces. Let's say that this is the x direction and this is the y direction. So let's sum the forces in the x direction equals ma in the x direction. Well, what are the forces in the x direction? There aren't any. No forces in the x direction. What does that mean? 0 equals ma in the x direction. Is the mass 0? No, the football has some mass. So what must be 0? A in the x equals 0. So if you have a projectile, there is no acceleration in the x direction. Now let's sum the forces in the y direction equals ma in the y direction. Well, there is a force in the x direction. Negative mg equals ma. So what is the acceleration in the y direction? Well, negative 9.8 meters per second squared. Yes? Okay. So now on the AP test, they might tell you just to use 10. 9.8 meters per second squared is pretty close to 10 meters per second squared. I'm not going to do that, but they might have you do that, and so to make the math easier, so you don't need a calculator as much. But so this is the acceleration in the y direction. And what do we notice about this acceleration? It is constant. And if the acceleration is a constant, what does that allow us to use? the kinematic equations. So you can, but this is only in the y direction. Now in the x direction, the only kinematic equation we need is, well, our displacement in the x direction is equal to the velocity in the x direction times time. Well, what is that velocity in the x direction? Well, we have to look at the picture. And in this case, there is a velocity in the x direction, right? There is a velocity in the x direction, and that's going to be my initial velocity times the cosine of the launch angle. So Vx equals, the velocity in the x equals V naught, this velocity times the cosine of the angle of incline. Okay, so you would have to use a little trig to figure out what that is based on what's given in the problem. But in the y direction, well, look, we have delta y equals, well, actually, let me start with the first one. Keep them in the same order. Right, we have the final velocity in the y equals the initial velocity in the y plus acceleration in the y times time. And what is this acceleration? Negative 9.8. You got to put in the negative because it's down. If you're going to say, now, by the way, sometimes the problem or a book will say down is negative. I mean, down is positive, and so then it would be positive 9.8. But I always make down negative and up positive. This is the average velocity in the y direction times time. Let me go on screen here, make sure I'm on screen. Oops. You should be thoroughly sick of these equations by now because we've been using them for so long. So these are the equations that you're allowed to use now when you're looking at this object in the y direction. Now, what's the same in both equations? What's the same here as over here? Time. Okay, so in these equations, time. So really what's happening, it's kind of like the object is moving in the x direction and the y direction at the same time. Okay. And so so now this allows you to solve lots of different problems. And so what you have to do is ask yourself, always when you're looking at a projectile, okay, what is the initial velocity in the x direction? Sometimes it's 0. Like what if I just take a rock and I just drop it out of a window or something? It's just going to fall straight down. So its velocity in the y direction increases in a negative direction, but its velocity in the x isn't going to change, right? And then, but what if I throw an object like this horizontally? Well, what's it going to do? It's going to go, go like that. Okay, so, but these two objects are going to have the same kind of motion in the y direction. I mean, if you were to look sideways at this falling down like this and this falling straight down, and you were looking at it sideways, they would look the same. Okay. And so this is, and also remember, if you're at the very tippy top, what's true at the very tippy top? The velocity in the y direction equals 0, right? Because it's changing direction. It's at its maximum height. So it was going up and it's about to go down. So in the y direction, it has to stop. What is the velocity in the x direction? Well, it's whatever it was before. It's a constant. Remember, the velocity in the x direction is a constant. Let me zoom out. Okay. So this is just a very quick review. Make sure that when you're looking at projectile motion problems, you pay close attention to what the initial velocity is in the y direction, what the initial velocity is in the x direction. The velocity in the x direction stays constant. Why? Because there is no force in the x direction. There's no wind resistance. Nobody's pushing on it or anything. A projectile is only under the influence of gravity. And in this class, we never include air resistance. And since the acceleration of gravity is a constant, we can use the kinematic equations to solve problems. Okay? Now, here's what you're going to do next. You're going to do an AP Physics free response problem. I'm going to show it to you under the screen. And then what I want you to do is I'm going to give you about 20 minutes to work on it. And so for some of you it might seem really super easy, but it's not as easy as you think. You really have to put some effort into it. So here it is, and I'm going to pass it out, or my substitute teacher will pass it out. And everyone will get your own copy, but you have to do it in your notebook, okay? Because here's the paper, and what does it say? Don't write on this, okay? But they're going to give you a situation where you've got sphere A and sphere B. Thoroughly read this, and then do what it says for part A and part B. And then look at part C, okay? Well, you probably can't read it, but I'm going to hand it out here in a minute. But I'll just read it out loud. It says, in a clear, coherent paragraph length response, and this is not something, well, I had you write summaries, right, of essential questions, but in a clear, coherent paragraph length response, explain why the spheres reach the ground at the same time, even though they travel different distances. Include references to your answers to part A and B. Now, I guess this is worth, on this particular AP test, this was worth 7 points. Okay? Now, part A is only worth 1 point. Part B is only worth 1 point. Part A and B are really super easy. Part C, the explanation, is worth 5 points. And you really need to write a good, clear, coherent paragraph explaining why. It has to be logical, it has to make sense. Okay? So that is so I'm going to so if you're the substitute teacher, please pass out the problem and give the students 20 minutes to work on it together. Put the answer in your notebook, and then what I'd like you to do is, after you've written your paragraph, I want you to compare your paragraphs, pass them around, and then I would like the A in each group. Sorry, A's. I want the A in each group on your whiteboard to write out your paragraph that the group kind of reached consensus on. Okay, so pass out the worksheet, spend 20 minutes on it, and when you've written your paragraph as a group, write the paragraph out. I picked the A. If somebody has really neat handwriting and they really want to be the writer, you can get somebody else. I'll tell you what, the A is in charge of deciding who writes the paragraph, and for your group. And then then I'll pass out a solution guide to it, and we're going to grade it. You are going to grade it in red pen. Okay, and we'll see how you do on this problem on the AP test. Okay, that is all for now.